Hello everybody, my name is Xavier Rodo. I'm working in Subsea 7 as a installation engineering lead. And today I would like to have a short presentation about how do we safely plan and conduct riser replacement operations. So this is quite different to all the presentations we had before. It's mainly focused on operational focus. Yeah. So the plan for this presentation is to give you a bit of introduction of what is riser replacement for us. Then I will have some slides which details a bit what are the risks that we are facing to and how do we manage them. I will show some examples of Subsea 7 vessels, installation vessels for FlexLay, and go a bit deeper with one of them. And then after I will list the key points that we usually focus on from the start of the project when we do a riser replacement or riser recovery based on the risks that I will highlight before. And then a short slide giving you an extract of lessons learned that we usually take into consideration at the start of the projects. So I don't have a slide showing Subsea 7 locations, but I guess all of you know, and there is you can go to the website. So as introduction, what is a riser replacement operation? So first, why do we do it? I think several presenters have already said it. Life extension of the field, but also end of the life of the riser, damage to the product, either accidental or due to fatigue, but it can be also new requirements like increase of flow for flexibles, but for other type of products we can have increase of requirements of controls or power. The configurations that we see mainly in the North Sea are static risers pulled through J-tubes, but also dynamic risers like steep wave, lazy wave, reversed pliant wave or pliant wave, and the lazy S. And I will, in the next slides, I will mainly mention about this tethered wave configuration. So I just wanted to give you a bit of overview. What are the key steps that we need to have in mind when that we are focusing as a really start when we do riser replacement. And first I will show you, this is showing an example of a step-by-step subsea snapshot of a riser being recovered, starting, and this is one example starting from topside end, but we do also the other direction. So giving that direction, the first thing we think about is topside disconnection and lowering of the topside end with the pull-in wire. Then we need to transfer it to the vessel, transfer the topside end to the vessel, either with an intermediate step with a crane like here, and then second step to the moon pool, like with this example. Then we have handling of the topside end on board the vessel, so working on it at the moon pool area or the working area, and then taking it through the lay spread, and then bringing it to the storage unit like a reel or a carousel. We have the wave and shaping, so it doesn't look, it looks very easy on the spot, but sometimes it's leading to some challenges subsea in order to manage well the product bending radius due to the buoyancy section design. Hold down tether disconnection. If we have a tethered wave configuration, it needs to be handled via counterweight in order to get good control of our buoyancy section when we recover it. Then we need to think about accessories removal on deck. You will see a nice picture later on. And then subsea and management. Either we recover a static flow line already connected to it and we break off the connection on board, or we have a subsea connector flanged to the pipe that we need to handle on board. For the installation, it's roughly the same key steps that we focus on, except that the installation can be a complete different process, especially subsea. Here is an example of, again, topside and first hand for installation, so which is not the same as going reversed from the recovery I showed before. So topside and handling on board the vessel as a first step is focused, and we have transferred the topside end to the floater with the pull-in wire. Accessories assemblies on board, like buoyancy modules and friction clamps. Counterweight management in order to manage well the buoyancy section to get it as flat as possible and avoid compression on top side. Wave shaping, which is again managed by the vessel, but also the counterweight can play with it. And tether connections. So if we have a tethered wave, we need to manage to get the wave down and manage the connection afterwards. And then subsea and connector installation on board, or directly down. Usually the subsea and handling on board the vessel is usually much easier than topside end. So that was to give you just an overview of how we have generally how the operation go for recovery installation of a riser. As a portfolio for only riser replacement, this is the on the last decade plus. This is the projects that Subsea 7 has performed for only riser replacement. If we look at only recovery or pure installation, and the list is much bigger. So this is just to give you the track record we have. And also we have the ongoing Statoil subsea line modification project, which has started a couple of months ago, or several months ago, and will go on during 4 years. And we have also a background, a strong track record also worldwide, not only in the North Sea. So we have, in Australia, we had a project where flow lines were replaced, and we have an ongoing project also now, but we have also performed riser replacement in Africa and also in Canada and also in the other part of the North Sea. And also with 3 dots means also Brazil. Actually, we have also very long-term contracts with Petrobras where we regularly replace products there. So now risk management. Which risk do we manage almost all the time in this kind of projects, and then how do we mitigate them? So I have 3 slides just showing list of risks and where the consequence can be, and then what do we do? So and I will focus mainly on the recovery operations, because for installation it can be also additional risks that we can have. So limited knowledge of annulus, or with only visual inspection of outer sheath. So sometimes this is risk, because if we have some ingress in the annulus and the outer sheath damaged, then we can have some pollution risks. But also we can have if we have a lot of elements clamped onto the pipe, we have experienced already some outer sheath burst due to increase of differential pressure and localized pressurized gas into the annulus. So mitigation for that is having annulus monitoring, basically, which was very much detailed before today. PPE, in case if there is a risk of pollution, and annulus venting system to be in place. O deviation can be also expected, and in that case, then we may have challenges to deal with a sliding bend stiffener. So this is a case of a non-FPSO, for example. But also we can have also on the other way around, we can have risk of loose accessories if the OD is decreasing. And we don't have magic plans for that, but the aim is to plan for contingency procedures should this happen, which is sometimes very challenging to put in place. Flexible bore content, which is usually if we recover a pipe, we need to know what is inside instead of in case we need to break off the subsea connection, and then we'll be exposed to the content. So the consequence could be pollution on board the vessel, and also how to manage it. So basically we need equipment to store the contents, having the right PPE, having contingency procedures in place, and also have a good knowledge about the decommissioning which was performed before. So here's a picture. It's an example of riser recovery where we broke off subsea connection from flow line to riser, and we pumped up the content which was getting out from the riser column from the late hour. Also, we can have risk of bend stiffener latching mechanism, which is non-functioning as we wish, and that is definitely something which can delay very much the operations. And usually it's with our vessel in close proximity to the floater. So I will come back to that later. So mitigation to that is having a bend stiffener latching mechanism which has a proper design which is suitable to be reused 20 years after its first installation, if the lifetime is 20 years. But also have reversible procedures in case basically we are stuck with this system not working. So then that will allow us to get a bit more away from the floater. Vessel dependence to floater equipment. So typically a winch, the pulling winch is usually is the item that we use on board the floater, and sometimes we have seen that there is only one winch on board the floater and no spares. So then this can be causing a lot of delay. So basically plan for backup procedures and backup equipment also on board the floater is big mitigation to have in place. Closed eye tubes at bottom ends with potential debris. We have seen that recently where we can have basically dropped object when we start lowering down the topside end out of the eye tube, but also we can have this item to damage the product also. So a survey of the eye tube is very necessary in order to ensure that we have nothing, but also the design of the top side to be so that there is no risk of dropping anything into it. So and then this is linked to the page before. Extending operation in close proximity in simultaneous operation in restricted weather. So this is it's a big. It's always a big subject in every project when we come with our vessel that close to the floater, like we can see here, and where we don't want to stay during several days, basically. So the consequence is to have we can have restricted activities on board the production unit, but also if something happens, we can have then an unplanned increase required operational window, and that is linked to the alpha factor selected. Mitigations is definitely to limit as much as possible the subsea operations linked to a topside end transfer, and also always plan to reverse if something happens. Extensive marine growth. This is definitely happening when we recover a 15 years old product or 20 years old product. And the consequence of having this marine growth is, as you can see here, he's having very heavy-duty manual operation to be done on deck, but also having very wet and slippery conditions on board. So mitigations for that is to know exactly what to wait for, and so having done a pre-survey, and then plan our operations and especially the schedule according to that. But also working area to be designed for having this kind of material laying around, and also cleaning tools to be planned with a lot of spares, because they do break off easily. Dropped object is also a very common actually risk to any riser operation, whether installation or recovery, and that obvious consequence could be a damage to existing subsea structure. And the main mitigations we have is a very thorough risk assessments that we perform with the client team and the vessel and all the parties necessary, but also planned shutdown from the operator is seen as a mitigation. So we see here an example of operation that was being held on the Njord field, for example, where one station vessel was straight above all the risers, basically. Sorry. Now I will show you what Sub7 vessels can do, and with one slide per showing the main vessels that we are which are FlexLay dedicated vessels operating in North Sea mainly. So the well-known Scandi SG, which has a FlexLay tower and two cranes, a 400-ton crane and 50-ton crane, and moon pool to perform the FlexLay. And then a lot of good characteristics which are shown here, and it can do any kind of subsea construction and FlexLay operation, basically. Sorry, I'm mixing up the switches all the time. Scandi 7, which is a bit smaller, having still a FlexLay tower and a 250-ton crane on deck, and basically the same layout of deck as the Scandi SG, roughly, and a bit different specs. We have the Normand Oceanic, which was originally a kind of sister ship to Scandi SG, which is now going on its way to have a very different design soon, but still the same cranes as the Scandi SG and the moon pool. And at the moment, no FlexLay system. It has been used with the horizontal lay spread already. And the 7 Pacific, which has been used only slightly in the North Sea, and with still a FlexLay tower, 260-ton capacity and a 250-ton crane, and a back deck crane also. So I'll go a bit in detail of the Scandi SG during a couple of slides, just to show you how we deal with riser replacement, or what do we use for riser replacement. So basically for storage, there is an under-deck carousel, which is 3,000-ton SVL and 24-meter OD, so a very large storage capacity. But also the back deck is close to 2,000 square meters capacity, so we can handle multi-ray drive system on board. And here's a picture of a four slots RDS, so equivalent to this one, on board Scandi SG here this summer. Lifting equipment we have on board this vessel. We have the FlexLay tower, we have the two cranes, and we have an ANR winch on top of the tower, like most of the FlexLay tower. And we have four gantry hoists in the moon pool array in order to handle equipment in a moon pool array in an efficient way. And we have also deck winches, 2 deck winches on deck, close to the moon pool to manage the product. So in order to manage containment, we have very actions which can be generic to any kind of vessel. for this action of containment. So we procure IBC tanks and a pumping system to pump the contents. We always make a closed volume around if we need to break off and fitting connection. So we'll close the volume around it to contain the content which is spreading out. PPE needs to be worn, so right PPE for marine growth, but also right PPE if we are exposed to pipe contents, like proper gloves, face shields, and masks. And also we are using the ROV capacity on board this vessel is quite extensive due to its very safe launch and recovery system, which is suitable to safe overboarding and recovery of the ROV until 6 meter HS. And it has also a capacity of lifting equipment in case we have heavy rigging or heavy installation has to be handled, up to 270 kilos in water. So key points to plan for recovery. So first about platform operations. So what has been highlighted before via the risks list is contingency procedures to be in place, and that is also valid for vessel operations. To allow, or not to allow, but in case we have a difficult disconnection of the topside line, but also function testing of the equipment on board the floater needs to be happening well before, such as we have a good assurance of using the equipment. Vessel operation, thorough planning and early planning of containment operations, such as everybody agrees on the method for handling this in case we have risk of pollution. This is usually a topic which takes time to all agree. Thorough planning of operations at working area while heavy cleaning is going on, because basically the cleaning operation when we recover risers is always taking a lot of personnel, so we need to plan basically simultaneous operation on board the vessel for doing other stuff also. Reversible operations to be planned, as said before, especially when we're in close proximity to a production floater, and scheduled to be clearly revisited when the survey of the riser to be recovered is to be done due to marine growth, extent of marine growth. And so this is very valid to pipe cleaning, because we need to have the pipe cleaned to go through the tensioner of the light tower, but we need also for buoyancy modules and friction clamps and bend restrictors, and all that removal of this equipment takes time. Subsea operations, counterweight connection or disconnection. This is something which has big focus, and we try to use permanent clamps if possible. And linked to that, we always focus on having the least as possible subsea installation of temporary heads onto the product. And then trials to be planned if we use subsea installable heads. And then the last slide about the key points is about design requirement, which we always foresee at end of the projects, and we try to reuse at start of new projects, but always difficult to influence that actually so utilization of temporary installation heads to be designed in view of recovery operations, so that when we have a brand new pipe, we really need to be sure that the way we install it, it's retrievable basically. Assessment of heads design with permanent features. If we need to have some installation heads to be installed and that needs to be used again for the recovery, then we need to include some some anodes, for example, for having it ready for recovery in many years after. Permanent accessories design interface with installation contractor for head connection and riser instability. So that is always what we find out at the end of the projects. Riser configuration is usually usually a challenge because the configuration is usually given at under stage and always changes through the project. And at the end, we always end up with much more buoyancy section, much more buoyancy uplift than the start of the project, which is impacting schedule and impacting methods usually. So, topside band stiffener latching mechanism selection to be done in according to think about recovery again. Monitoring equipment onto the pipe to know what's going on the annulus, especially for to avoid burst, for example. And reuse of permanent equipment to be thoroughly assessed if we need to do it 20 years after its first installation. So according to as found condition or design also originally. So just to give you a table of little extract, little abstract of lessons learned that we have in our lessons learned database. This is only a small extract about flexible riser recovery, and maybe one or two are linked to installation also. And so basically we have a database which is that we are using at every start of every project. Do you have any question?
Any questions for Xavier? When it comes to handling of the flexibles, when you recover them, are there any special care that you don't do any damage or harm to them? Because usually a lot of the companies want to investigate on this and don't want any extra damage.
Now our base case is to respect the product limitations, the same as for installation. It's not because it's gonna be scrapped that we want to damage it. No, we do everything to keep it as is.